absolutely great to be here in Dubai. Much warmer than Cambridge, so it's fantastic to be here. So I guess we're all here about AI, and the reason is we've kind of reached this inflection point now in the industry, right? Over the last year or so, the pace of AI development, but importantly, the application of AI in industry has massively accelerated. And we think one of the key drivers behind this is the advent of AI models known as large language models. These are things like ChatGPT, Bard, that everyone is now very well aware of. And that's what we want to really focus on today. So let me just give you a quick agenda of what we want to discuss today. So ultimately, we're in the DIFC. Everyone cares about making money, right? That's why we're here. So what we want to do is we want to talk to you about, firstly, give you a background to what LLMs are and how they've progressed. And we want to use that as a canvas to explain to you where we feel the biggest gaps lie in the commoditization of LLMs. Now, that could be for new companies to start in this space or for people looking to invest. We've then had the opportunity to work with some of the biggest VC funds in Europe, and we've collated a list of certain aspects of AI companies that might signal black swans, good things to invest in versus red flags. And finally, we have some exciting announcements to make that George has alluded to with regards to our partnership with Coinvesting Capital. So why would you want to listen to us, and what do we know about LLMs? So we're very fortunate. In a British fashion, I'm not going to speak about myself. I'm going to speak about Vatsal, Aidan, and Vyas, who are lead AI engineers. We're really fortunate to have some world-leading AI expertise in LLMs. So a bit about Vatsal, Vyas, and Aidan. Vatsal and Vyas are twins, actually. Pretty much very similar. I think Vatsal's a little bit better. But that's because his brother's not here, but I hope he's not listening. But yeah, the three of them studied engineering at the University of Cambridge. That's why we're called Cambridge AI Studios. We all studied at Cambridge. And they're exceptional students. They all ranked in the top 10 of their cohort of over 300 engineers. So for many, getting into Cambridge is a massive achievement, but these guys found that a bit too easy, so they decided to do something a bit different. Based on that, they then got these really highly coveted PhD positions in the machine intelligence lab. And for many engineers in the space, especially in speech and LLMs, this is one of the most renowned institutions for AI development. They've published a load of papers on LLMs in top-tier journals. And importantly, they also have a range of expertise in developing LLMs in an industrial capacity. So Vatsal was part of the team at Meta with Patrick Lewis that actually developed RAG, which is what a lot of people are alluding to now. Patrick was also involved in the team in developing Llama 2. Aidan has worked with Microsoft, and Vyas has been working on adversarial robustness systems with AWS. And a tiny bit about me, I come from a slightly different background. I actually studied medicine first to be a doctor, quickly realized, actually, I like tech. Did a PhD in bioinformatics, computational biology, much like yourself. And my specific expertise is building vertical specific AI. So I've been in charge of developing LLMs in the healthcare setting. So that's a bit about us. It's a lot about our academic background, but it's also important to explain to you a bit about what we've been doing with LLMs over the last year or so. So prior to this exclusive partnership, we've had the opportunity to work on LLMs with a range of different people. So the first bracket is in an adjunct capacity with some of the largest AI companies. So Samba Nova Systems, you might have heard of in the news. They recently released the largest 1 trillion parameter model, the highest valued AI startup in the world, valued at 5.1 billion. So we have been working with them with regards to developing certain aspects of their LLMs. We also work with Chai Research, which are a leading entertainment LLM company, and we'll touch on them a bit later towards the end of this presentation. We've also worked with institutions, much larger institutions, that are just looking to develop AI. They don't know how to do so. So the NHS and the Council of Health Insurance in Saudi Arabia. And finally, from a different side, a different perspective, we've been working in particular with Dawn Capital, who raised a 700 million generative AI fund and have been doing the technical due diligence for them in terms of their generative AI investments. So that's a bit about our background in LLMs, and I'm going to hand over to Vatsal, who's going to give you, to start with, a background to what LLMs are and where they've come from.
Thanks, Sharon. So my objective in these next 10 minutes or so is kind of explain the history of how we got to a point from nothing to ChatGPT being so good, and then the remaining 5 minutes explain why it's so bad. So to begin, to make sure we're all on the same page, to me, artificial intelligence is anything which involves automation. We've been throwing around this buzzword a lot, but it's good to be all on the same page. Artificial intelligence has been around for a long time. And within that, we have a subset which we call machine learning. Machine learning is anywhere, as we know. We have any kind of data which we're training on, typically historic data, it doesn't have to be historic. And within that, we have a subset we call deep learning. And deep learning specifically making use of an architecture that we call neural networks. And in this talk, I want to talk about how deep learning is applied to a specific vertical of natural language processing. Because beyond natural language processing, deep learning can be applied to computer vision, which is images, tabular data, graphical data, and so on. So now let's begin with the timeline of where, as a field of natural language processing, how we have evolved from the basic methods we had in 1963 to what we have in 2024. So back in 1963 was when the idea of neural networks was first proposed. But the issue was that there were limiting barriers to making this a reality to actual and real products. So it wasn't until 2009 that we had sufficient data and sufficient compute power to be able to actually train these systems to actually do tasks that we are interested in. And up till the year 2013, the method in which we used for natural language processing was this concept of using what we call word embeddings. So word embeddings was the idea that every single token in our English vocabulary or any other language, and token I mean like a subword, can be represented by what we call an embedding. An embedding is basically a vector representation which represents each word in some kind of meaningful space. I've shown a depiction here in the top right, so you can kind of see that words which are similar in meaning, for example, in the bottom right, we have things related to computers, are close to one another, and other words, for example, related to politics, are also clustered together. But of course, this is a massive simplification because in reality, the size of the embeddings that we're working with are 768 dimensions, and I can't really imagine beyond 3 dimensions, so you can imagine how rich that space is. But the point is, up to like 2013, the most methods we use out in NLP were based on these kind of embedding-based approaches and manipulating them to do specific tasks that we're interested in. And this kind of continued all the way till 2017. So the way you would do any kind of NLP task, let's say sentiment classification. You have a sentence you want to classify as positive or negative. People would develop like bespoke architectures, hand-selected how they want, how many features they want, what neural network architecture they're using, and train it on some data from scratch to do that task. But in 2017, there was a massive paradigm shift that I'm sure a lot of people here already know about. And that's when Vaswani, very famous in the NLP community, from Google released this transformer architecture. And then what Google did by 2018, they said, so there's a huge amount of data sitting out there on the internet, like Wikipedia articles, websites, and various other sources of information. But our models, our language models, can't really make use of it right now because it's unlabeled. We don't have annotation to say this sentence is positive, this sentence is negative. It kind of is just sitting there. So in 2018, this was the first idea of how we came to the idea of pre-trained language models. So what Devlin did, a guy who created the BERT model, he said, okay, I'm going to take a random sentence of Wikipedia. Let's take the sentence, it is most likely that King Henry V, blah, blah, blah. And he randomly masked out a certain word. Let's say he masked out the word likely. And now he trained a language model, specifically the transformer architecture, to predict which word was masked out. And suddenly we had an objective function. So he was able to repeat this process in tons and tons of different sentences from Wikipedia. And what resulted is the model that he called BERT. And the idea with BERT was that it suddenly had a very good understanding and grasp of the English language. And what that meant is that other tasks, for example, maybe I was interested in sentiment classification. Before 2017, I was taking my own architecture, training from scratch to do that task. But after 2018, with the release of BERT, I could take BERT and just tweak it a tiny bit. I call that fine-tuning on my specific subset of data to be able to do the task of sentiment classification. So this was really a paradigm shift. And since the advent of BERT, there was a huge number of other pre-trained language models which came about. For example, T5, Roberta, Albert, Electra, I can keep naming XLNet, and so on. But this paradigm shift was also short-lived because, as we all know, in 2022, there was another big paradigm shift of how the NLP community reacted. That, of course, was the release of ChatGPT. So what really is ChatGPT? It's what we call an instruction fine-tuned language model. So what they said is, okay, it's great we have these pre-trained language models which have a great grasp of English, but I can't really use them directly for any task I want. So what they did was instruction tuning, and they did multitask instruction tuning. It gave it lots and lots of examples of lots of different prompts with corresponding answers. This could be something like translate to Arabic the sentence, summarize this article, give a review on this post, and lots of different tasks from existing data sets that existed out there. And what resulted was the first instruction fine-tuned language model, which was able to understand lots and lots of different prompts and could be used in a universal way, and which is kind of what took the whole media by storm in 2022. Other tweaks they did were things like reinforcement learning human feedback, which meant all they were really trying to do was align the model's outputs with values we have as humans. And those were 3 values they defined, which we call the 3 H's. The models have to be helpful, honest, and harmless. So this is what made ChatGPT so effective. But ironically, when OpenAI released ChatGPT, it was actually a closed source model. So they were the first in this whole NLP community to actually release closed source models, because prior to this, everything was open source. All these models I've discussed beforehand are available directly on Hugging Face. I can download the model weights and use them as I deem fit. So after 2022, with the release of ChatGPT, there was suddenly another AI race of all the big tech and a lot of other institutions trying to release their own large language models, all instruction fine-tuned language models. So this included Llama 2 from Meta, GPT-4, Mistral, Gemini, Cloud, and so many more. Zephyr is another example. So this was up to 2022, 2023, and still continues. Even Cloud that I've listed here just came out 2 days ago. And where are we going from here? So I think a couple of other people already talked about this, but 2024, from my experience, has been the year of RAG. RAG saying there's a lot of problems in our current systems with instruction-tuned models. They're great at language, they can do a lot of tasks, but at the end of the day, they're only trained on public data or a certain domain of data. And if I want to use them in a certain specific application, let's say I'm a company, or let's say I want to use in a medical application, I want to force my large language model to only respond to, let's say, information which is present in a medical textbook. How do I enforce that? So people have come about with the idea of RAG, retrieval augmented generation, which was created actually by Patrick Lewis a few years before this, but it's only really been popularized since it's been plugged in with these large language models. And the idea of RAG is just twofold. It has 2 components, retrieval and synthesis. We have a medical textbook, and I want to ask the question, okay, I've got a swelling on my ankle. What is my diagnosis? I don't really trust ChatGPT to give me an answer directly, but I want it to be embedded, or maybe a better word would be grounded on this medical textbook. So what happens is it takes this medical textbook, and we have this retrieval step. And the retrieval step, we kind of retrieve the most important information to answer that specific question. And once you retrieve the relevant information, we pass the relevant information with the question to my synthesis model, which could be something like ChatGPT. So you use ChatGPT for what it's good at. So at this point, where I've stopped at 2024, this is where we are as a community. Everyone's doing RAG, everyone's using these large language models in this kind of setup. You can go further, you can fine-tune these both parts of the RAG setup, but at the heart of it, one of the issues we feel is that at the end of the day, large language models are not good at logic. They are language models. They're good at English or whatever language they're trained on, and they can model language very well, but they cannot derive deep insights. So at this point, I want to stop and pause to give back to Sharon to make one of the announcements to our product to show how we leverage all of these technologies and how we're going to build on top of this to go even further to derive these deep insights that I'm referring to.
Cool.
Sharon Jones.
Thanks, Vatsal. So the first thing that we're very excited to announce today in partnership with Coinvesting Capital, they funded us to develop a contextual intelligence platform called Herd. So this does exactly what Vatsal was saying. We want to build upon the existing paradigms in LLMs, but importantly, be able to derive insights from data. Now, you might think, why are we called Herd? What does that mean? The idea is that as humans, we like to follow the crowd. We want to know what other people are doing and do the same. And this drives so many different markets around the world. Financial markets, politics, marketing. So what we're doing initially is we're using a deep learning architecture, and Vatsal will go into the technicalities of this in a second. And initially, we're building this for cryptocurrency and decentralized finance. So the idea that this is a rapidly emerging market, but principally in this field, there's a lot of information that retail investors can access, but simply find it difficult to get access to, and secondly, do not have the right insight from the data. So let me give you a little taste of some of the functionalities that Herd will have in this vertical. So the first layer is information access. So a big problem right now is there are a lot of noise around the place. There's social media posts on one website. One media agency is saying one thing. YouTube influencers are saying something else. So what we want to do is provide the opportunity to synthesize information across a massive range of sources, leveraging the scalability of AI. So you might want to ask the question, what are people's thoughts on Bitcoin today? It will then synthesize the largest voices or the most predominant factors in the field. You might want to ask questions from the blockchain. Again, this is something that's readily available in decentralized finance, but most retail individuals have no idea how to use it. So the idea that we can use large language models as a mouthpiece to insert prompts and then gather and synthesize the information. So that's layer one. Now, layer two is where we get really exciting. So we have all this information available on the open internet. We also have proprietary data. And stage two is all about how we generate insights using the patterns and correlations that are impregnated in this data. So in particular, for cryptocurrency and decentralized finance, we want to look at the factors, the attributes that we have that's openly available that might lead towards higher or healthier investments versus those which have certain attributes suggestive of red flags or rug pulls. And then finally, layer three is to then connect this with wallets to execute. So you might want to ask a prompt, hey, Herd, when people feel positive about Solana again, please buy me some Solana. And this is the idea that we can connect insights, prompts, synthesis, and execution. So that's a bit about what Herd does from kind of a top-level view. And I want to pass back to Vatsal, who's going to talk about how we're building on the existing paradigms in LLMs. And this connects a lot of the things that our previous speakers have spoken about.
So the idea here is we want to kind of go beyond this RAG setup of just being able to retrieve information. Because as Sharon mentioned, we want to be able to derive insights. So what are the stepping stones to achieve that? The first layer, as everyone knows here, is data is the main driving force of what this is going to give us value. And we have different modalities of data. We'll have white papers or textbooks related to each of the coins. We can have social media sentiment. We have live articles which come every single day from lots of different websites. You can have influencer videos. You can have tabular data about all the different coins or the influencers, specific details about them. So we need to be able to ingest all of this data. In the typical RAG setup, we will have just this module, the retrieval module, which is able to retrieve information over all these different data sources and then synthesize using a large language model into a human readable format. But what we are proposing instead is something similar to the mixture of experts, but a mixture of models where you have bespoke systems designed specifically for tasks which they're optimized for. For example, you might have a system which is an influence validator, which tells you, based on prior data, the statements an influencer is making, how correct actually they are, based on the data they're providing. So the idea is we have lots and lots of different systems which are bespokely designed for this specific purpose and can actually derive the logic you want, rather than relying on the large language model to do the logic part. Because the large language model, as we all know, is the language model. And we can only really rely on to collate all the outputs from these bespoke systems and provide a very easy to access point for the end user. So that's kind of the high level for how Herd is working. Now I quickly want to touch on that Herd is one possible product that we've been discussing here as the avenue for an AI company. But where else are the gaps in the market of where AI could be useful for lots of different use cases? So I've discussed the idea of how we have these three stages. We used to have these unsupervised language models called the pre-trained language models. Then we had instruction-tuned language models, such as ChatGPT, and then they could be fine-tuned for specific use cases or verticals. So in the first bracket, what I would say, these are what we call model as a service. A model as a service is super saturated. There are lots of big tech players inside there. Lots of people are releasing lots of language models. So if I was an investor, if I had that capital, I would not try and invest into a company which is trying to develop these models directly, because you require of the order of millions of dollars to be able to compete against any of these big players, which are all kind of using the same architecture, same public data they're training on, and trying to fine-tune the best instruction-tuned language model. So model as a service is not somewhere it's not easy to be competitive in. The second part is the concept of IaaS, infrastructure as a service. So a lot of people are saying, for these models to be actually used in real life, you need to be able to deploy these models. They need to be hosted somewhere for lots of different companies. And that creates an opportunity of where these models are going to be deployed. But once again, there's big players here, like AWS, CoreWeave, and lots of other like Azure type of companies like this. So once again, it's very difficult to compete in infrastructure as a service. So what can new AI companies do? Where are the gaps? The first part is what I'm saying here is the business-specific LLM. When you fine-tune any of these models on a specific domain or a specific vertical, on your data, you have an edge. Because no one else can do what you're doing. It's on your specific setting and niche vertical, which either does not interest a big player because it's niche, or they simply don't have access or the domain knowledge that you do in that vertical. And that kind of links to the idea of proprietary data. If you have proprietary data, that's the money, because your model is trained on that data and no one else's model can be trained on that data either. On the deployment side, where else could AI startups be useful? One concept is ensembling. And ensembling could be looking at different approaches of how they can combine lots of different models to get better performance for specific use cases. Another direction could be uncertainty estimation. Right now, we're using models for performance, but can you get an output which tells your model how much you trust the output? If it can give you a confidence score, something like saying in a medical setting, it's going to diagnose me with a certain disease. How much do I trust the output? If it's very confident, maybe I can trust the system. But if it's not so confident, maybe we want a hybrid setup where you pass over control back to a human doctor. Another idea is continual learning. Data is changing all the time. How do we keep updating our models? If there's a startup solving these kind of issues, then once again, it has an edge. A fourth one could be adversarial robustness. As we go from the point where AI is moving away from academic circles into real-life businesses, there's the risk that adversaries will try and take advantage of these deep learning systems to do unintended behavior. For example, there's the idea that everyone knows that your voice is used, for example, in banking apps. If you say a certain word, maybe you can hack into someone else's banking information. So how do we design our deep learning systems to be robust to potential adversarial attacks, which can be more of a requirement in 1 or 2 years, I expect. Another direction could be the idea of personalization. How do we cater to specific audiences? Right now, ChatGPT is not personalized. It doesn't cater to what type of person you are necessarily. You can prompt it to be, but it's not truly personalized. It's mimicking personalization. So how can we get personalization to various different attributes? That's on the deployment side. On the training side, there could be the idea of efficient training. These models are huge, getting bigger and bigger. Do we need distillation? Do we need quantization? How can we handle these issues so that is actually computationally feasible for these models to be deployed? Another direction could be trustworthy LLMs. Someone mentioned hallucinations. These models make things up. How do we tell if models make something up or not? And finally, the concept of federated learning. In a lot of use cases, our data is very private. We cannot afford for the model to leak the data out to different use cases. Maybe typically in a hospital setting, you have data distributed across lots of different hospitals, but that data cannot leave the hospital. So federated learning will look at approaches like you train on all these different data sources without ever needing the single model to transition between the different points inside here. So all of these areas are where I call the gaps in the AI market for LLMs, or where companies can capitalize and benefit rather than trying to create their own next large language model, as they say. So now that I've covered kind of the landscape or where there's benefits or where AI companies can benefit, or startups at least, I just want to hand over back to Sharon to give our second announcement.
Great, thank you, Vatsal. So our second announcement is we are establishing an incubator for AI companies in Cambridge. So you might ask, why Cambridge? Well, firstly, I live there, so it's not too far to go there. But secondly, it's actually the largest producer in Europe of university spin-outs. So as you can see, actually globally, it ranks first in terms of the per capita, the number of individuals that have raised over £10 million for their university spin-outs. There's been 23 unicorns in Cambridge since 2005. And also, Cambridge attracts a lot of investment. There's a lot of venture available for it. Now, despite saying that, and despite the clear metrics about Cambridge, there is a massive gap. And the issue is, academics like us don't like to start businesses. And that's often because there's not much of a nudge to get you into entrepreneurship. I think that really touched nicely on the previous talk just before this. So what we've seen has been working really effectively in Cambridge is the development of these incubators. They're not necessarily investment firms. What they do is they give academics that nudge to take an idea from academia and try and transition it into industry. And that's exactly what we want to do in Cambridge. And I think a big problem is the kind of unknowing, you don't know who these people are. So what we do is we are impregnated within the academic community at Cambridge. Vatsal is a fellow at Downing. Similarly, I also supervise students at Cambridge. And we want to leverage those connections to really push what we see in terms of academia into a company. And specifically, we're going to be focusing on two main things. We want to focus on what we know best, and that's deep learning. Specifically, we'll be looking at companies centered around NLP, but also open to computer vision and other forms of deep learning. And then secondarily, we'll also be looking at kind of broader companies within the ML landscape. And we want to provide three main things. Firstly, we want to provide technical support to companies. Often, initially, founders are by themselves. They need technical support to be able to push them to a MVP or a proof of concept. Secondly, academics don't often have a business background, and we want to provide strategic alignment that we've learned from our time outside in the real world to help them produce a proposition that's ultimately suitable for capital endorsement. So we have, obviously, connections with capital co-investing now, and we want to provide that stepping stone for these companies to actually move away from a university spin-out and into actually a real company. So that's a bit about what we're going to be doing in Cambridge. And I guess there are a lot of investors in this room today, and we wanted to kind of finish off with a little bit of a case study about what you might want to look for when LLM companies in particular come through your door. So what I want to do is I want to give you a very basic checklist. This is not a technical due diligence at all. This is just perhaps some little factors that you could look for when someone comes through your door. And what we want to do is ultimately provide you some kind of signals in terms of black swans, companies that are interesting, might be worth a deeper look at, or red flags, things that perhaps signal to you this is probably a bit of a gimmick, probably not worth your time and investment. So let's start with a case study. This is a case study of a company that we actually worked with, Chai. So what they do is they build chatbots with very specific personalities. So here we're giving an example of Yoda, but in reality, a lot of the use of this company is for very weird personalities that I probably won't go into because this is televised. But that's what Chai is used for. So a bit about the background of Chai. Their team are friends of ours, AI researchers from Cambridge. They have software engineers who are ex-Meta. They've relocated to Silicon Valley. Fine. Now the data, they gather every single message that is sent between their users, okay? So all of this data is stored as well as feedback. Do people like the response? As you see a thumbs up or a thumbs down with ChatGPT, they have the exact same system in place. Now, in terms of their LLM technology, they're using an instruction fine-tuned model as a base and then are fine-tuning it further. So they're using a 6 to 13 billion parameter model. Not the biggest model in the world, quite a small model. And this enables them to have pretty fast inference, which means they can run it quickly, and it's less expensive to run. In terms of competition, there are actually a number of players in the space. Character AI is the one with the biggest market share. But a lot of these competitors use ChatGPT. And finally, in terms of evaluation, they actually care about real-world metrics. So they want to know what their users actually feel about the messages. They don't really care about academic metrics in terms of the outputs. So that's the first company. And the second company is a company called ChatGP. Okay, not ChatGPT, ChatGP. So GP stands for General Practitioner. So this is a medical AI startup. And what they do is they listen into conversations with your doctor. They'll convert that into text, and then they'll create a summary so that the patient and the doctor can remember what happened. The team are economics and chemistry graduates from MIT with front-end software engineering experience, okay? No NLP experience, no AI experience. In terms of data, they're using a lot of open source or readily available data sets. And this is not really in the medical domain. They're using data actually from news and media articles. In terms of their LLM technology, they're simply using ChatGPT through an API. In terms of competition, no one really in this space. And then finally, in terms of evaluation, they're looking at quite academic metrics. So they're looking at the Rude score, which is a measure of how well the summary overlaps with what you'd expect from a gold standard. So I'm going to give you guys maybe 10 seconds. I'm interested to see what you think. Could you put your hands up if you would invest in Chai? Okay, a few of you, right. And who would invest in MedGP or ChatGP instead? Okay, Enzo would, okay. Right, okay, yeah, I think this is a bit of an exaggerated example, but absolutely, I think we're completely with you. I think Chai makes a lot more sense out of the two for a range of reasons. So one thing that we look for, it's not the most important factor, and by the way, I just want to say this is a checklist that we've come up with. It's not necessarily the gold standard one. You guys can all have your own kind of checklist. But in terms of team, ultimately, to really create a defensible moat, you need to have NLP expertise in your team to be able to push forward the performance of your models and differentiate yourself from these kind of off-the-shelf solutions. So having NLP engineers or scientists and founders is a positive sign, and individuals who don't have much background in NLP before 2023, a bit more of a red flag. The second is what model are they using to basically run their LLM? So are they using proprietary models that they've taken off the shelf but have now fine-tuned to their domain, or are they simply using an API? That's a really important factor to look into. Then let's talk about defensibility. So one way of defensibility is data, which we'll come on to, but another way of defensibility is actually the way that they are using these LLMs. So that could be ensembling LLMs or using them in a completely novel way. Now, the thing with AI is it moves very quickly, so defensibility is never long-term, but even if it's an initial kickoff, it can provide a defensible advantage. Then the fourth thing that we look at is application, right? There's no point trying to be the jack of all trades. There are already massive companies in the space doing this, and you're not going to win. What you need to do is focus on building very, very vertical-focused LLM models that are very catered to a specific use case. In terms of data, now, data is your defensibility. Data is your cash cow. So basically, it's a thing that we always like to look for is how are companies looking to keep their data? Are they storing it in any way? Do they have any particular evaluation metrics? And then evaluation, right? In the first talk, we heard that no one cares about classic metrics, evaluation metrics they use in academia. What you really care about is real-world business performance. So seeing a company that cares about these from the foresight is a really nice sign to see. And then what are the opportunities to innovate? When you use open source models like ChatGPT, there's nothing else you can really add on top of them. Fine, you can do a bit of prompt engineering, you can optimize the prompts, but you can't really do anything downstream. So looking for individuals that have ideas, but also architectures that are amenable to this. And finally, especially in Europe and the UK, ethics and governance is a very, very important factor. Now, we know in 2025 there's regulation going to come in for AI in Europe, and having architectures and founders that are aligned with ethics is very important from the outset. So I guess that's a bit of an overview in terms of a due diligence checklist. Hopefully that was an interesting overview into what LLMs are, where we feel LLMs could succeed, and also some things to look out for the next time an LLM company walks through your door. Thank you.